The question today is on Hooke's law, and the question reads, the three springs shown below are identical and of negligible weight. The extension produced on the system of springs is 20 centimeters. So we have the diagram as shown. Then you're asked, determine the spring constant of each spring. So in this question, we are going to determine the spring constant by first considering the extension for this part. Let's call it extension 1, and the extension for this other part, let's call it extension 2. So for this particular part, first part here, the spring constant, of which I'll call Kp, P for parallel because the two strings are arranged in parallel. So that is given by twice K, where K is the spring constant for a single spring. So because they are in parallel, so the spring constant tends to be higher. So that's why we multiply by 2. And for this second part, the spring constant is just K because it's 1. So this information here will help us when we are working out these. So we are asked to determine the spring constant of each spring. So first we begin by the total extension, which is given by E1 plus E2, the extension for the first part, and then we add it to the extension of the second part, which already in the question we've been told is 20 centimeters. So right here, the extension produced on the system of springs is 20 centimeters. So by Hooke's law, force is equal to the spring constant times extension, and therefore that implies that extension is equal to force over K, and that also implies that E1, the extension for the first part, is given by force over the spring constant, so that is force over Kp, and the force that the two springs support is 20 plus 20. Remember, the springs are of negligible weights, so we have this 20 newtons load plus the other 20 newtons load, so they support 40 newtons. So we are going to have 40 newtons over Kp, and Kp here is 2K. So we have 2K, and that finally means we have 20 over K. Similarly, for E2, so E2 here, again applying Hooke's law, we are going to have the force. So this extension on this spring is as a result of this 20 newtons load. So we are going to have the force 20 newtons over the spring constant. So here the spring constant is K because it's just a single spring, so over K. So that we are going to have this equation. E1 plus E2 will give us the total extension, and E1 is 20 over K plus E2, which is also 20 over K, and that is equal to 20 centimeters. So in order to get the value of K, we multiply all through by K, and that will give us 20 plus 20 is equal to 20K. So that is 20K is 40, and K therefore is 2 newtons per centimeter. We can also opt to write this in SI unit. So we have K is equal to 2 newtons per centimeter, so that is over 1 centimeter. So in order to convert it in its SI unit. So on the numerator we have 2 newtons, on the denominator 1 centimeter into meters, that is 0.01 meters, and this gives us 200 newtons per meter. So the two answers are the same, 2 newtons per centimeters and 200 newtons per meter. That is it for this question. Thank you for watching. Hope to see you in the next video.